Hello friends, in this session we will take up a topic called trigonometry. We have to study only the basic concepts and the basic formula in trigonometry. We don't have to get into the great details of the subject or the chapter here. Okay, first of all, let's try and understand a right angle triangle. When we say a right angle triangle, what we mean by saying that is this is the triangle in which one angle is 90 degree. Let's say this angle is theta. Let's give them some names also, A, B, C as sides, right? Now, let's consider this angle theta. For angle theta, right, we define some ratio of sides, right? And we give them some names. First of all, for angle theta, the opposite side is equal to AB, right? In the given triangle, opposite side for the angle theta is AB. Adjacent side is equal to BC. Hypotenuse is fixed, whichever angle you take. Hypotenuse is AC, right? Now, using three items, this AB, BC and AC, we can create various ratios of AB, BC and AC, right? Let's say, for example, AB by AC, this is one of the ratios. BC by AC, this is another ratio. Similarly, we have AB by BC, another ratio. We can also take AC by AB. We can also take AC by BC, and we can also take BC by AB. Okay. Now, for angle theta, define this ratio AB and AC. This AB and AC, for angle theta, AB is the opposite side. So it is opposite divided by hypotenuse. Now, opposite divided by hypotenuse is defined as sine. So it is sine of theta, right? So sine of any angle is equal to opposite side divided by hypotenuse. Similarly, this BC upon AC, let's define first for angle theta. BC is adjacent side for the theta angle. So it is adjacent side divided by hypotenuse. And the name given to this ratio is cos of the angle theta. Okay. Now this AB upon BC for angle theta, if you define, it is opposite side divided by adjacent side. Now opposite upon adjacent, the name given to this is tan. So it is tan theta. So in a right angle triangle, if we are given with the sides and an angle, for every angle we can identify the opposite side, the adjacent side and hypotenuse, and accordingly these ratios, opposite upon hypotenuse is defined as sine, adjacent upon hypotenuse is defined as cos, opposite upon adjacent is defined as tan for that angle, right? The angle for which we have identified opposite, adjacent and hypotenuse. Alright. Now if you look at AC upon AB, now they see this AC upon AB is actually hypotenuse divided by opposite side. And that is defined as, it's like it is actually inverse of this ratio. So it will be 1 upon sine theta, that is cosec theta. So the definition of cosec theta is hypotenuse divided by opposite side. Similarly, this AC upon BC, this is for angle theta, if you look at closely, it is hypotenuse divided by BC is adjacent side. And this is defined as sec theta. And this BC upon AB is defined as adjacent side upon opposite side, and this is defined as cot theta, right? So the basic definition of all the trigonometric ratios we have identified. Now what do we mean by trigonometric ratios? Trigonometric ratios are sine, cos, tan, cosec, sec and cot. These are trigonometric ratios. Okay, so from the triangle it's very important to understand what is the meaning of sine. So I'll write like this: for theta, the ratio involving the opposite side is represented by sine. Similarly, ratio involving the adjacent side is defined as cos. Okay, and involving both of them, like this opposite upon adjacent, is defined as tan, right? Now let's create some formula from here. So once again we have taken this triangle, and for this triangle we will define different relations. The first relation is the ratio and inverse relation. Ratio and inverse relation. Okay, I'll directly give you the formula. For ratio, let's say tan theta is equal to sine theta divided by cos theta, which can also be taken as sine theta equal to tan theta into cos theta, right? Similarly, the second one will be cot theta. Cot theta is equal to cos theta divided by sin theta. From there you can see clearly that if you cross multiply, cos theta will be equal to cot theta into sin theta. Okay. Then this is the ratio relation. Now inverse relation. Let's say cosec theta. Cosec theta is equal to 1 by sin theta. From there you can see directly that sin theta into cosec theta is equal to 1. Alright. Similarly, sec theta is actually equal to 1 by cos theta. From there you can see directly that sec theta into cos theta is equal to 1. Similarly, cot theta is equal to 1 by tan theta. From there you can see that tan theta into cot theta is equal to 1. All these are supposed to be memorized directly. Okay. Now the next set of formula, it is also called square relations. Square formula or square relations. Now for that, I'll just write the Pythagoras theorem for this triangle. The Pythagoras theorem for this triangle will be AB square plus BC square is equal to AC square. So if you divide by AC square in all the terms, you will get AB square upon AC square plus BC square upon AC square plus equal to AC square upon AC square. Now this can be written as AB upon AC whole square plus BC upon AC whole square equal to 1. Now look at this angle theta. For this angle theta, AB is the opposite side and AC is the hypotenuse. So that means opposite upon hypotenuse, which is sine. So AB upon AC can be written as sine theta square. Similarly, this BC side is adjacent for angle theta. So BC upon AC can be written as cos of theta square. This is equal to 1. And whenever you take a power of a trigonometric ratio, it will look like sine square theta plus cos square theta. Right? It is equal to 1. So one square relation is this. So I'll write it here. One square relation is sine square theta plus cos square theta equal to 1. Right? You can derive different things from here. For example, sine square theta can be taken as 1 minus cos square theta from here. Right? Cos square theta can be taken as 1 minus sine square theta from here. Okay. And from there you can also calculate sine theta or cos theta in terms of the other one. Okay. Similarly, from this only you can find the other square relations. The other square relations are like this. Sec square theta minus tan square theta is equal to 1. This is the other one. From here you can see that sec square theta is actually equal to 1 plus tan square theta. And tan square theta is equal to sec square theta minus 1. Right? So it's very important to memorize these rules directly. So this one is one important rule. This is one important rule. And the last one would be cosec square theta minus cot square theta equal to 1. From here you can see that cosec square theta can be taken as 1 plus cot square theta, or cot square theta can be taken as cosec square theta minus 1. Right? So these are the important square relation that you have to memorize. Okay. Now let's take some questions on the basis of what we have done till now. Let's say question 1. So till now what we have done is we have done trigonometric ratios. They are also, in short, they are called T ratios. T ratios means trigonometric ratios. Alright. And what do you mean by trigonometric ratios? Trigonometric ratios mean sine, cos, tan, and then their inverse. Sine inverse will be cosec, cos inverse will be sec, and tan inverse will be cot. So there are 6 total trigonometric ratios. Now the idea is that if one ratio is given, you can find the other ratios also for that angle. Okay, so let's take question 1. If we say, let's say cos theta is equal to 8 by 17. The question is find other trigonometric ratios trigonometric ratios, or we could have simply said T ratios, other trigonometric ratios for angle theta, right? So for angle theta, one of the trigonometric ratio, that is cos theta, it is given. Find all the other trigonometric ratios for theta. That means we won't need to find sine theta, we need to find tan theta, we need to find sec theta, cosec theta, as well as cot theta, right? Now there are two ways of doing this question. Alright, so first let's take method 1. Method 1 is the formula method. Herein we only use the formulae. Okay, formula method. How do we do that? We have done only two types of relation. One is the ratio inverse, right? And the other one that we have done is the square relations. Okay, we'll use only these two. So in this method 1, let's say already cos theta is given. So cos theta is equal to 8 by 17. From there straight away sec theta will be equal to inverse of cos theta. So 1 by cos theta, which is inverse of cos theta, that is 17 by 8. So one of the other trigonometric ratios we already have got. Now we also have a formula sine square theta plus cos square theta from square relations, that is equal to 1. So from here we can see that sine square theta is equal to 1 minus cos square theta. So that means sine theta will be equal to square root of 1 minus cos theta, right? 1 minus cos square theta. Now cos theta value is given 8 by 17. Put it here. So sine theta will be equal to square root of 1 minus 8 by 17 whole square. Calculate it normally. It will be square root of 1 minus 64 upon 289. Take LCM, it will become root of, in denominator 289 and numerator will be 289 minus 64. So it is root of 225 upon 289. Now 225 square of 15 and 289 square of 17. So it is 15 by 17. So what do we get? We get sine theta value here. So I'll use this space. So we already have cos theta, that is equal to 8 by 17. We have just calculated sine theta, that is equal to 15 by 17. We also know from the ratio formula that tan theta is equal to sine theta divided by cos theta. Now here sine theta is 15 by 17. Cos theta was already given 8 by 17. So what happens? 17 and 17 get cancelled and we'll get 15 by 8. Right? Now inverse of sine theta will be the cosec theta. So cosec theta is equal to inverse of sine theta, that is 17 by 15. And from tan theta, we already have tan theta equal to 15 by 8. So inverse of this, that is cot theta, will be equal to 1 by tan theta, that is 8 by 15. So as you can see, now we have calculated all of them. From cos theta, we directly calculated sec theta. From square relation, we calculated sine theta. Then by taking ratio of sine theta and cos theta, we calculated tan theta. By inversing sine theta, we get cosec theta, and by inversing tan theta, we get cot theta. So this is one method wherein we use the formula. Alright. There is another way of doing the same question. Let's take up. Now let's take up the second method, method 2 of this question. Now method 2 is also called the right angle triangle method. Okay, right angle triangle method. What we do in this, that we initially we draw a right angle triangle and we assign one of the angles as theta. So let's say this triangle was ABC and let's say this angle is theta. Now in this triangle, for this angle theta, cos theta will be defined as the ratio of adjacent is to hypotenuse. Now adjacent side here it is BC and hypotenuse is AC. And the value of cos theta is given 8 by 17. So we say that BC upon AC is equal to 8 by 17. So very safely we can take the value of BC as 8 and AC as 17. So BC as 8, AC as 17. Now using Pythagoras Theorem, that is AB square plus BC square is equal to AC square. From here we can calculate AB square, that is equal to AC square minus BC square. We have taken the value of AC as 17, so 17 square. BC as 8, so 8 square. 17 square is 289, right? So AB square is equal to 289 minus 64, which is equal to 225, which is 15 square. So we get AB equal to 15. So if I put AB equal to 15 here, now we have the values of all the three sides. Using the values of all the three sides, we can find every other trigonometric ratio. For example, for this angle theta, let's say sine theta. Now what will be sine theta? Sine theta will be opposite upon hypotenuse. Opposite side is 15, hypotenuse is 17. Inverse of sine will be cosec theta. So cosec theta is straight away from here 17 by 15. Similarly, tan theta can be calculated as opposite upon adjacent. Opposite side is 15, adjacent side is 8. From here we can inverse and we can get the cot theta value, that is 8 by 15. And from cos theta only, cos theta was already given, cos theta is 8 by 17. So from there itself we can calculate sec theta as inverse of cos theta, that is 17 by 8. So there are two different ways of calculation of other trigonometric ratios for a given angle. One is the formula method, and the other method is the method based on the right angle triangle. All right, let's take one more question on this. Now let's take up the second question. It says if sec x plus tan x is equal to 5, find all t trigonometric ratios for angle x. Right, so it's given that sec x plus tan x is equal to 5. And we have to find all the trigonometric ratio. That means we have to find sin x, cos x, sec x, cosec x, tan x and cot x. Right? So what should we do? There is a square relation that we had done. As sec square x minus tan square x equal to 1. Now look at this closely. It is a square minus b square, and we know that there is a formula for a square minus b square which says it is equal to a minus b into a plus b. We can apply that formula here. Okay, this will look like, this can be taken as sec x minus tan x into sec x plus tan x, that is equal to 1. From here you can see that sec x minus tan x is equal to 1 divided by sec x plus tan x. Now we also have sec x plus tan x as 5. So 1 by sec x plus tan x will be 1 by 5. So what we have here is sec x minus tan x is equal to 1 by 5. Right? Let's write these two equations together. We already have sec x plus tan x equal to 5. And we take sec x minus tan x is equal to 1 by 5. Alright. So, if you simply add these two equations, let's see what happens. If you simply add, tan x and tan x will get cancelled. Sec x plus sec x will be 2 sec x. And it is equal to 5 plus 1 by 5. In denominator, LCM 5 5s are 25 plus 1, that is 26 by 5. Okay, so this is 2 sec x is equal to 26 by 5. So if you divide by 2, you get sec x is equal to, from here you get sec x is equal to 13 by 5, right? So from there you can directly see that cos x will be inverse of that, that is 5 by 13. From here itself we can find the other ratios, okay? Or what you can also do is you can go back here and subtract. So I'll write those two equations again. Sec x plus tan x equal to 5. Sec x minus tan x equal to 1 by 5. And now you subtract. So if you subtract, what will happen? This becomes minus, this becomes plus. Sec x and sec x get cancelled. Tan x plus tan x is 2 tan x. That is equal to 5 minus 1 by 5. Now 5 minus 1 by 5, take LCM 5. In the numerator we will have 5 5s are 25 minus 1. That is 24 by 5. So what do we have? 2 tan x equal to 24 by 5. From here you get tan x equal to 12 by 5. Right? If you inverse, you will get cot x equal to 5 by 12. Okay. So what all do we have now? We have sec x, we have cos x, we have tan x and we have cot x. We still have to find sin x and cosec x. Let's do one thing. We know that tan x is equal to sin x upon cos x. From there you can see that sin x actually is equal to, by cross multiplication, it is tan x into cos x. So tan x value, here it is 12 by 5. Okay. Cos x value we have already calculated, it is 5 by 13. So if you put here, 5 and 5 get cancelled and we have 12 by 13. Perfect. So what do we have now? We have sin x is equal to 12 by 13. And by taking inverse of that, we have cosec x which is equal to 13 by 12, right? So we have calculated all the trigonometric ratios for x. Okay. Now let's move on to this situation of values of trigonometric ratios for specific angles. Now what are the specific angles that are important for us? The angles that are important for us are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These are the angles which are really important for us. Okay, and we should know the values of all the trigonometric ratios for these angles. Okay, so let's try to recall. For 0 degree, sine 0 degree, this is equal to 0. Cos 0 degree, this is equal to 1. Tan 0 degree, that you can calculate by division also, 0 by 1, that is equal to 0. Alright. Similarly for 30 degree, and now if you have the values of sine, cos and tan, you can always calculate cosec, sec and cot by taking inverse of these values. For 30 degree, sine 30 degree is equal to 1 by 2. Cos 30 degree is equal to root 3 by 2. Tan 30 degree is equal to root 3. No, it is 1 by root 3. It is actually again sine 30 divided by cos 30. So it is 1 by root 3. 45 degree. Sine 45 degree is equal to cos 45 degree and both of them are equal to 1 by root 2. And because both cos sine 45 and cos 45 are equal, so tan 45 degree, the ratio of those two will be equal to 1. Okay. For 60 degree, sine 60 degree is equal to root 3 by 2. Cos 60 degree is equal to 1 by 2. And hence tan 60 degree will be equal to sine 60 divided by cos 60. So root 3 by 2 by 1 by 2. So simply root 3. And finally, sine 90 degree. Sine 90 degree is equal to 1, cos 90 degree is 0 and tan 90 degree will be equal to 1 by 0, that is infinite. Okay. So from these values obviously you can find the other trigonometric ratios also, but these three are more important: sine, cos and tan for all of these angles. They are really important. You must memorize them. Okay, there is no other option. You directly have to memorize these values. Don't give any chance to yourself in this for any mistake. Just memorize these values. Now, there are some other values also that I'll just show it to you. If it is possible, you can memorize them. Okay, that is for 15 degree and 75 degree. Let's see. For 15 degree, sine 15 degree is calculated as root 3 minus 1 upon 2 root 2. Cos 15 degree is calculated as root 3 plus 1 upon 2 root 2. And tan 15 degree will be equal to sine 15 by cos 15. So 2 root 2 gets cancelled. And we are left with root 3 minus 1 upon root 3 plus 1. And if you rationalize by multiplication of root 3 minus 1 in numerator and denominator, it will give us 2 plus root 3. Right? So especially for 15 degree, this is what we have. If it is possible, you can memorize it. Okay. Now, similarly for 75 degree, actually 15 and 75 can be memorized together, because whatever was sine 15 will become cos 75 and whatever was cos 15 will be sine 75. So sine 75 degree is actually equal to root 3 plus 1 upon 2 root 2 and cos 75 degree is equal to sine 15, that is root 3 minus 1 upon 2 root 2. And from there you can calculate tan 75 degree, which is root 3 plus 1 upon root 3 minus 1. One second, this was root 2 minus root 3. And I'm sorry, I repeat. Tan 15 degree is root 3 minus 1 upon root 3 plus 1. And on simplification, rationalization, it becomes 2 minus root 3. Tan 75 degree is root 3 plus 1 upon root 3 minus 1. And on rationalization, it becomes 2 plus root 3. Right? So tan 75 degree is more, okay, than tan 15 degree. So tan 75 degree 2 plus root 3, tan 15 degree 2 minus root 3. Okay. So this is for 15 degree and 75 degree. And one very special formula that we have here, that is related to, let's say, there's one special formula, 90 degree minus theta. For 90 degree minus theta. Now this is very interesting. Sine 90 degree minus theta, you can memorize it is equal to cos theta. And similarly, cos 90 degree minus theta is equal to sine theta. That's exactly the reason for which we have seen that sine 30 degree is equal to cos 60 degree. Okay. Similarly, sine 60 degree is equal to cos 30 degree. We have also seen sine 15 degree equal to cos 75 degree, and so on. Right? That's precisely the reason, because the formula is sine 90 degree minus theta is equal to cos theta, and cos 90 degree minus theta is equal to sine theta. Okay. Similarly, tan 90 degree minus theta is equal to cot theta, and cot 90 degree minus theta is equal to tan theta. Okay. Right? So this is one important rule that you can memorize. Just with this only, you can also see that sec 90 degree minus theta will obviously be equal to cosec theta, and cosec 90 degree minus theta will be equal to sec theta. Okay. So these are the special formulae for 90 degree minus theta. Right? So I think more or less we have completed the entire theory for trigonometry that is required for us. Anything other than this, what we have done, anything other than what we have done right now will be of a higher level, which might not be necessary for us to be aware about. Okay, so our theory, I think it gets completed here only. Now just for sake of one more information, I'll add the values of trigonometric ratio, though it may not be required directly. Okay, you can say the value range for trigonometric ratios for various angles. In fact, simply the value range. Now the value of sine and cos, it always remains between -1 and 1. Right? So the value of sine theta or cos theta has to be between -1 and 1. So for any value of theta, both sine theta or cos theta, their value has to be between -1 and 1, inclusive of -1 and 1. Okay. So for any angle theta, the value of sine theta or cos theta, it has to be between -1 and 1. Similarly, the value of tan theta and cot theta, right? Sine theta, cos theta is this. Tan theta or cot theta, these values will be anything from -infinity to infinity. Right? So that means for any angle theta, the value of tan and cot can vary from -infinity up to +infinity. And the value of sec theta and cosec theta, this is very interesting. It does not belong to -1 and 1 or between -1 and 1. It is either below -1. So we can say it is in the set -infinity to -1 and union 1 to infinity. So just remember that sine theta, cos theta values cannot be beyond -1 and 1, and sec theta, cosec theta values cannot be between -1 and 1. It has to be beyond -1 and 1 because they are inverse of sine theta and cos theta. Sec theta is inverse of cos theta and cosec theta is inverse of sine theta. So just remember that sine theta, cos theta has to be within -1 and 1, and sec theta, cosec theta has to be outside -1 and 1. Alright, so this is one very interesting information that we have done. Also, there is another small information about the positive and negative sign of trigonometric ratios that you can memorize from the quadrants. We know that this is the first quadrant. In the first quadrant, the angles are from 0 degree to 90 degree. This is the second quadrant. In the second quadrant, the angles are from 90 degree to 180 degree. Okay. This is the third quadrant. In the third quadrant, the angles are from 180 degree to 270 degree. This is the fourth quadrant. In the fourth quadrant, the angles are from 270 degree to 360 degree. Alright. For any angle in the first quadrant, all trigonometric ratios are positive. Right. So let's take an example. If I say angle 43 degree. So for 43 degree, sine 43 is positive, cos 43 positive, tan 43 positive, and all the other are also positive. Whereas in second quadrant, if you take any angle in the second quadrant that is between 90 degree to 180 degree, sine and cosec are positive and others are negative. Right? For example, if I take 120 degree. So sine 120 degree value will be positive. cosec 120 degree value will be positive, whereas cos 120 degree value will be negative. Tan 120 degree will be negative. This is what it means. For the third quadrant, so for any angle that is between 180 and 270, tan and cot are positive. Tan and cot are positive. Okay. All the others are negative. So if I take an example, let's say for an angle 200 degree. So sine 200 degree, it will be negative because it is third quadrant sine. Tan 200 degree, it will be positive, right? Because tan is positive. And cos 200 degree will also be negative, right? Now for any angle in the fourth quadrant, that is between 270 and 360 degree, cos and sec are positive, okay? And all the others are negative. So for example, if I take an angle 300 degree and we say sine 300 degree, we say cos 300 degree, okay, and we say tan 300 degree. What can you tell us what will be the sign of each one? Let's see. Sine 300 degree, it will be negative, okay. Sine 300 negative, cos 300 degree positive, tan 300 degree negative. Just try and understand that, okay. You can also memorize it as ASTC, all sine, tan, cos. First quadrant, second quadrant, third quadrant, and fourth quadrant, right? So we have completed all the aspects of the theory part or theoretical aspect of trigonometry. Now let's go and solve some of the good questions. All right. All right. So now that we have done the formulae of trigonometry, let's start with these questions. Right. This is the first question. It says sine square 43 degree plus cos square 43 degree. For that we need a formula that is sine square theta plus cos square theta is equal to 1 irrespective of the theta value. Look at this closely. This is sine square 43 degree, cos square 43 degree. The only condition is theta angle has to be the same. So this is equal to be 1. That's it. So nothing else had to be done in this question. Okay. So only this formula has to be memorized. So if you remember the square formula we have, in which we had done cos square theta plus sine square theta equal to 1. We also had done sec square theta minus tan square theta equal to 1, and we have also done cosec square theta minus cot square theta equal to 1. Okay. Now let's take up the next question. Here it says which of the following pairs has the trigonometric ratio having same value, right? So let's first give them some name, that is A, B, C, D. All right. Now it says which of the following has the same value. So this is a pure question based on the value. Let's say A, sine 45 degree is equal to 1 by root 2. Tan 45 degree is equal to 1. Are they equal? No, they are not equal at all. Okay. Then B value. B has cos 30 degree. Now cos 30 degree, we have to remember these values, that is root 3 by 2. And tan 45 degree. Tan 45 degree is equal to 1. Again not equal. Let's say C. Sine 30 degree equal to 1 by 2. Cos 60 degree. Alright, that is also equal to 1 by 2. So this is the correct situation. So answer is C option. Alright. If you check the third one, last one also, tan 60 is root 3, sine 45 is 1 by root 2. So they are also not equal. So answer is C option. Okay. Now let's take up the next question. Now this question said which of the following is not an identity. Now sine square A plus cos square A equal to 1. This is an identity. Sine A is equal to tan A into cos A. Let's check. We have tan A equal to sine A divided by cos A. So from here by cross multiplication we can have sine A is equal to tan A into cos A. Let's check again. The second option is sine A equal to tan A into cos A, right? So this is also correct. Now the third one, 1 plus cot square A equal to cosec square. Oh, this is a direct square formula, right? So this also is correct. Now the last one, 1 minus sec square equal to tan square, right? This is wrong because we have 1 plus tan square A equal to sec square A. This is the real formula. So from here 1 minus sec square A should have been equal to minus tan square A, right? Here in the fourth option it says 1 minus sec square A is tan square A, right? So this is wrong. This is not an identity. Not an identity, right? So what is the question saying? Which of the following is not an identity? So the answer is D option, right? Be careful. What is the question asking? Which of the following is not an identity? So the answer is D option. All right. Now the next one. Now this question again is related to the range of trigonometric functions or trigonometric values. Which trigonometric function can be equal to or greater than 1 but not below it? So if you remember, I'll write it here. Sine and cos both belong to the set of values from -1 to 1 inclusive of both. They cannot be beyond, right? So they have to be less than 1, can't be greater than 1. So in this case, which trigonometric function can be equal to or greater than 1 but not below, right? So sine is wrong, cos is wrong, because they have to be below 1. Okay. Now if you remember tan values, tan and cot, both these values belong to they belong to the set from -infinity to +infinity. Oh, so that means my tan and cot values will be below 1 as well as above 1. So that also is wrong. So clearly secant is left. So that is the answer of the question. But let's check. What happens in sec and cosec? What you have to understand that sec and cosec are simply inverse of sine and cos. Right? Sec is 1 by cos and cosec is 1 by sine. Now we know that the sine and cos are between -1 and 1. So their inverse will definitely be more than 1 or below -1. Right? So greater than 1, it will only be sec and cosec. Alright, so they have, and in fact if you have done earlier, it is between -infinity to -1 inclusive of -1 union 1 to infinity. Right, here there is one clarification that is required. Which trigonometric function can be equal to or greater than 1? And we consider only for positive values. Alright, so just for positive values it has to be above 1. So in that case only secant or cosecant could have been the answer. Okay, now let's go to the next question. Now this question says simplify this expression. Alright, let's do the simple process. Let's take LCM of these two expressions. It will be 1 plus cos alpha into sin alpha, and in numerator it will be cross multiplication, so it will be sin alpha into sin alpha, that is sin square alpha, plus 1 plus cos alpha into 1 plus cos alpha will be 1 plus cos alpha whole square. Right? So it will be equal to sin square alpha plus 1 plus cos square alpha. If you open it will be 1 plus cos square alpha plus 2 cos alpha. It is a simple application of a plus b whole square. Divide by 1 plus cos alpha into sin alpha. Now you see sin square alpha plus cos square alpha will be equal to 1. And there is already a 1. So it is 1 plus 1 plus 2 cos alpha divided by 1 plus cos alpha into sin alpha. So it is equal to 1 plus 1 is 2. 2 plus 2 cos alpha divided by 1 plus cos alpha into sin alpha. So in numerator if you take 2 common you will get 1 plus cos alpha, and in denominator we already have 1 plus cos alpha into sin alpha. So what will happen? 1 plus cos alpha, 1 plus cos alpha will get cancelled, and the final answer will be 2 divided by sin alpha. Now it is sin alpha in denominator. If it goes in numerator, it will become cosec alpha. So 2 cosec alpha is the final simplified form of this expression. So this expression is equal to 2 cosec alpha. Right? So this is the answer of this question. Now the next one. Now this question says sin alpha is equal to 5 by 13. Right? And alpha is between 0 to pi by 2. Now this only means to say that all the values, all the trigonometric ratios are positive. Now we have to find cos alpha, tan alpha and cot alpha. There are two methods of doing this. One method is the triangle method. So let's simply draw a right angle triangle and assume one angle to be alpha. So if this is ABC, then sin alpha will be equal to, from this triangle, AB upon AC, opposite side upon hypotenuse. And the value of sin alpha is given in this case as 5 by 13. So very safely we can take AB equal to 5, AC equal to 13. And from there, AB equal to 5 and AC equal to 13. From there we can simply calculate the value of BC. Now for BC we have a square root of AC square minus AB square, that is 13 square minus 5 square. Or we can also use the Pythagorean triplet, because we know that 5 is to 12 is to 13 is one Pythagorean triplet. Here we already have 5 and 13, so the third side has to be 12. So whether you do it by calculation or if you memorize the ratio, in any case this has to be 12. So this side is 12. Now once you get all the three sides, you can easily calculate any trigonometric ratio. Say for example cos alpha. Cos alpha will be equal to, adjacent side upon hypotenuse. So adjacent side is 12, hypotenuse is 13, right? So if suppose we have to calculate tan alpha will be opposite side upon adjacent side. So it is 5 upon 12, right? Now, so we have already sine alpha, cos alpha and tan alpha. By inverting them, we can get cot alpha, sec alpha and cosec alpha. So cot alpha will be equal to 1 by tan alpha, that is invert of tan alpha, 12 by 5. Sec alpha will be equal to inverse of cos alpha, that is 13 by 12. And cosec alpha will be equal to inverse of sine, that is 13 by 5. Right? So this is one method of doing this question. Now, the other method can be, let's look at this carefully. Method 2 can be taken as, we can take help of formulae. We have a formula sine square alpha plus cos square alpha equal to 1. And it is given that sine alpha is equal to 5 by 13. So put the value of sine alpha in this and calculate cos square alpha. So sine square alpha will become 5 by 13 whole square plus cos square alpha equal to 1. So from here we have cos square alpha equal to 5 by 13 square goes to the other side. So it is 1 minus 25 by 169. So if you simplify, in denominator 169, numerator 169 minus 25. So it is 144 by 169. So cos square alpha is equal to 144 by 169. So this gives us cos alpha is equal to, take the square root, 144 will give us 12 and 169 will give us 13. So now we have sin alpha as well as cos alpha. From there we can calculate tan alpha. Tan alpha will be equal to sin alpha divided by cos alpha. Now sin alpha is 5 by 13, right? Divide by cos alpha, that is 12 by 13. So 13 and 13 will get cancelled and we will have just 5 by 12, right? Similarly, if you invert all of them, you will get sec, cot and cosec. So this is I think say cot alpha will be simply inverse of tan alpha, that is 12 by 5 and so on. Okay, so there are two ways of doing such questions. Now let's take up the next one. Now this question says cot x is equal to 2, right? Now from here I'll use the triangle method. Let's say if I take this as 90 degree and this angle as x and this side as ABC. Now we can say cot x will be equal to, now cot is defined as adjacent side divided by opposite side. Now adjacent side in this case is BC divided by opposite side is AB. And the cot x value is 2. So this can be written as 2 by 1 equal to BC by AB. So very simply we can take BC as 2 and AB as 1. So BC as 2, AB as 1. So by using Pythagoras theorem, we can calculate AC equal to square root of BC square plus AB square. Now BC square is 2 square, that is 4. AB square is 1. So it is 4 plus 1, that is 5. So it is root 5. So this value is root 5. So from there we can get sin x. Sin x will be equal to, now sin x will be opposite side, that is 1, divided by hypotenuse, that is root 5. Similarly, cos x in this case will be equal to adjacent side, that is 2, divided by hypotenuse, that is root 5. So cos x is equal to 2 by root 5. Alright, now simply put these values here. So this gives us, from the first one, it is 2 plus 2 sin x. So first let me do one thing, 2 common. So it is 1 plus sin x into 1 minus sin x. Very good. Now we have 1 plus cos x. So it is 1 plus cos x. And from here we have 2 common. So 2 common, 1 plus cos x into 1 minus cos x. Wow. So 2 gets cancelled and in numerator we have 1 plus sin x into 1 minus sin x. So a plus b into a minus b will become a square minus b square. So 1 square is 1 minus sin square x will be written like this. In denominator also 1 plus cos x into 1 minus cos x. So 1 square is 1 minus cos x square is cos square x. Now 1 minus sin square x, we have the identity cos square x plus sin square x equal to 1. So from there we can see that sin square x is equal to 1 minus cos square x and cos square x is equal to 1 minus sin square x. Great. So in numerator we will have cos square x and in denominator we will have sin square x. Now we also know that cos x upon sin x is cot x. Now here it is cos square x upon sin square x. So it is cot square x. Oh, so we did not have to do all these, right? So this question is a direct one because cot x is already given 2. So cot square x will be simply equal to 2 square, which is 4. So answer of this question is 4, and we did not need these values that we have calculated here. Okay. So just be careful. Sometimes it may happen that these values are required. Sometimes it may not be required. Okay. So anyways, the answer is 4 for this expression. Alright. Now let's take up the next one. So we have to simplify this. Let me write it again. It is sine t plus cos square t divided by sine t. Alright, so let's take LCM. Sine t. In numerator it will be multiplied, so it becomes sine square t plus the other one remains as it is, that is cos square t. Now sine square t plus cos square t is 1, so it is 1 upon sine t. Now 1 upon sine t is equal to cosec t. Right. So if you look at the option, right, so B option is the correct answer. So this was a rather simple question. Okay. Now next one. Now this is a very interesting question. It says 1 plus 2 sec square a tan square a minus sec to the power 4a minus tan to the power 4a is equal to, let me rewrite it like this. It is 1 minus sec to the power 4a minus tan to the power 4a plus 2 sec square a into tan square a. So what I have done is I have just taken sec to the power 4a and tan to the power 4a in the beginning. Now let's keep one separate. Let's take minus common from all these terms. So what will happen? Minus common. In the bracket we will have sec to the power 4a positive plus tan to the power 4a also positive, but this plus 2 sec square into tan square a will become minus. So this can be written as 2 sec square a into tan square a. Right? Why? Because it was already plus sign. We have taken minus sign common, so it becomes negative. Now look at this closely. It is 1 minus sec to the power 4a is actually sec square a square. Tan to the power 4a is actually tan square a square minus 2 into sec square a into tan square a. And this becomes the formula of a minus b whole square. Right? So this is actually 1 minus sec square a minus tan square a whole square. Now we also know that sec square a minus tan square a is 1 for any angle a. So it is equal to 1 minus 1 square, or it is 1 minus 1, which is 0. So answer of this question is simply 0. That's it. Alright. Now let's take up the next one. Now this question, it says 1 minus sin a cos a upon cos a into sec a minus cosec a, and sin square a minus cos square upon sin cube a plus cos cube a. Let's do one thing. Let's write it as 1 minus sin a into cos a divided by cos a into, now this sec a can be written as 1 by cos a minus this cosec a can be written as 1 by sin a. Right? Now the other side, look at this carefully. Sin square a minus cos square a. We know that a square minus b square is equal to a minus b into a plus b. So apply that, you will get sin a minus cos a, right, into sin a plus cos a. Okay. And in the denominator, it is sin cube a plus cos cube a. Look at this carefully. Here we have a formula a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. Right? Here in place of a we have sin a. In place of b we have cos a. So we can write this as sin a plus cos a into sin square a square means sin square a, minus ab means sin a into cos a. Alright. And plus b square would mean cos square a. Okay. Now see, sin a plus cos a cancelled. Now this side we have 1 minus sin a into cos a divided by cos a into. Now in the bracket we can take LCM as cos a sin a. And in numerator we will have sin a minus cos a. Okay. And on the other side, the other part, sin a minus cos a is there. And in denominator, look at this. The sin square a plus cos square a will become 1 minus sin a into cos a. This term will remain as it is. Alright. Now this whole thing, 1 minus sin a cos a, 1 minus sin a cos a gets cancelled completely. This sin a minus cos a and this sin a minus cos a gets cancelled completely. And here this cos A and cos A gets completely divided, and this sin A remains. So it is actually 1 divided by 1 by sin A, right? Which is equal to sin A. Okay. So the answer of this question, the most simplified form is sin A. Alright. So you have to be just careful and apply the basic formula. Alright. So more than trigonometry, it was an algebra question because it had factorization in it. Okay. Now let's go to the next question. Now this is a very interesting question. It says cos theta minus sin theta is root 2 sin theta. So cos theta minus sin theta is equal to root 2 sin theta. Let's do one thing. Send this sin theta to the other side. So we will have cos theta equal to root 2 sin theta plus sin theta. So if you take sin theta common, you will get root 2 plus 1. Alright. Now the question says find cos theta plus sin theta. Right. So it is cos theta plus sin theta equal to. Now see, we have already calculated cos theta equal to sin theta into root 2 plus 1. So cos theta is equal to sin theta into root 2 plus 1 plus sin theta. So this gives us, take sin theta common, you will get root 2 plus 1 plus 1. That is eventually sin theta into 2 plus root 2. Right. So this is the maximum that you can say about this. Right. So this is the most simplified version of this situation. You can do one more thing. You can take root 2 common. So root 2 into sin theta, and inside the bracket from 2 you have taken root 2. So root 2 will remain. From root 2 you have taken root 2. So 1 will come. Now this sin theta into root 2 plus 1 is eventually cos theta actually. So it is root 2 cos theta. Right. So you can say either this sin theta into 2 plus root 2 is answer, or root 2 cos theta is the answer. Alright. So this is how we can do this question. Right. Obviously it will depend on the options also. Let's take up the next question now. Now the next question is one of the difficult questions. It says x sine cube theta plus y cos cube theta is sine theta cos theta, and x sine theta is equal to minus y cos theta is equal to 0. So from here we can see that x sine theta is equal to y cos theta. In other words, what we can say is y equal to x sine theta divided by cos theta. Okay. Let's put this value of y in place of y in the first equation. Now the first equation is x sine cube theta plus y cos cube theta equal to sine theta cos theta. So if I put y equal to this x sine theta cos upon cos theta, this will give us x sine cube theta plus, in place of y we take x sine theta by cos theta into cos cube theta equal to sine theta into cos theta. Now what happens? Let's do one thing. Let's take x sine theta common. Now from the first one, if you take x and sine theta common, you are left with sine square theta. Now from the second one, you take x sine theta, you are left with cos cube theta by cos theta. Let me write it again. By cos theta is equal to sine theta into cos theta. Now this outside sine theta and the sine theta on the other side will get cancelled. And we have x into sine square theta plus cos cube theta by cos theta is cos square theta. This is equal to cos theta. Alright, now sine square theta plus cos square theta is 1. So x into 1 is cos theta. So x is equal to cos theta. So if you put x equal to cos theta in this one, you will have y equal to cos theta into sine theta divided by cos theta. What we are doing, we are putting the value of x as cos theta. So cos theta get cancelled and we have y is equal to sine theta. Fantastic. What is the question asking? The question is asking the value of x square plus y square. Now you see, x square plus y square will be simply equal to x square means cos square theta and y is sine theta. So y square would mean sine square theta. So x square plus y square is cos square theta plus sine square theta, which is 1. So answer of this question is just 1. Alright. Now let's go to the next question. Now this question says calculate the value of following expression. Alright. So here we just need the values, right? Look at this closely. It is sine 30 degree. That is 1 by 2. Cos 45 degree. That is 1 by root 2. You must have memorized these values. Tan 60 degree is root 3. Sine 60 degree is root 3 by 2. Cos 30 degree is equal to root 3 by 2. And tan 45 degree is equal to 1. So directly put these values, take care of the power and calculate properly. Now here it is sine square 30 degree. Sine 30 degree is 1 by 2. So it is 1 by 2 square plus cos square 45 degree. Cos 45 degree is 1 by root 2. So square of that, 1 by root 2 square minus tan square 60 degree. Tan 60 degree is root 3. So square of root 3. This whole thing divided by sine square 60 degree. Now sine 60 degree, where is it? It is root 3 by 2. So it is root 3 by 2 square minus cos square 30 degree. That also is root 3 by 2. Fantastic. So root 3 by 2 square plus tan square 45 degree is 1 square. Now first of all, this root 3 by 2 whole square, root 3 by 2 whole square will get cancelled. And in numerator will be left with 1 by 2 square is 1 by 4 plus 1 by root 2 square is 1 by 2 minus root 3 square is 3 divided by, in denominator we just have 1. So that is finished. So let's take LCM. It is 1 by 4 plus 1 by 2 minus 3. Let's take LCM as 4. Numerator 1 plus 2 2s are minus 3 4s are 12. Right? So 3 minus 12, that is minus 9 by 4. So the answer of this question is simply minus 9 by 4. So but you needed to memorize these values and use these values here. Alright, now let's take up the next one. In this question again we need values. So I'll directly put the values. Let's say sec 60 degree. Let's see, sec 60 degree is equal to 1 by cos 60 degree. And cos 60 degree is 1 by 2. So it is 1 by 2 which is equal to 2. Right? Cos 30, so let's say sec 60 degree is 2 plus 4 into cos 30 degree is root 3 by 2. So cos square 30 degree is root 3 by 2 whole square minus tan 45 degree is 1 divided by sin 60 degree is root 3 by 2 minus cos 60 degree is 1 by 2 plus tan 45 degree is 1. Right? So simplify, you will get 2 plus 4 into 3 by 4 minus 1 divided by this 1 minus 1 by 2, this together will become plus 1 by 2. So it is root 3 by 2 plus 1 by 2. Alright, now this 4 and 4 get cancelled. We have 2 plus 3 minus 1 divided by root 3 plus 1. So LCM 2, root 3 plus 1. This 2 goes in numerator. So 2 plus 3, 1. 2 plus 3 is 5. 5 minus 1 is 4. So it is 4 into 2 divided by root 3 plus 1. So it is 8 divided by root 3 plus 1. Now rationalization, because root 3 plus 1 is an irrational number. So root 3 minus 1 multiply divide, we will get 8 into root 3 minus 1 divided by root 3 plus 1 into root 3 minus 1 will become a plus b into a minus, that is a square minus b square. So root 3 square, that is 3, 1 square is 1. So it is 8 into root 3 minus 1 upon 2. 2 cancels 8 4 times. So it is 4 root 3 minus 1. Right? So answer of this question is this. If the value of root 3 is required, you can put it and get the answer as 4 into 1.732 minus 1. So it is 4 into 0.732, and that would have given us 4 2s are 8, 4 3s are 12, and 4 7s are 28, 29. So 2.928. Alright. Now let's take up just one more question. Now this last question is also based on the values. I'll directly put the values here. It is equal to tan 60 degree is root 3 into cos 45 degree is 1 by root 2. Sin 60 degree is root 3 by 2. Tan 45 degree is 1. Be careful about the sine. Now sin 30 is again 1 by 2. Cos 60 is also 1 by 2. Plus tan 30 is 1 by root 3. Now here this root 3 and root 3 will get multiplied. So this will give us 3 by 2 root 2 minus 1 and whole divide by 1 by 2 into 1 by 2 is 1 by 4 plus 1 by root 3. So in numerator, the max that we can do is take LCM as 2 root 2 and we have 3 minus 2 root 2. Similarly in denominator, take LCM, will be getting 4 root 3 and here we have root 3 plus 4. If you simplify, this will come out to be 3 minus 2 root 2 divided by 2 root 2 into 4 root 3 divided by root 3 plus 4 or 4 plus root 3. Okay. So 2 cancels 4 2 times. Root 2 cancels 2 root 2 times. So what we are left with is 3 minus 2 root 2 into root 2 into root 3 is root 6. Divide by 4 plus root 3. So let's do one thing. Let's rationalize it. 4 plus root 3. So the conjugate will be 4 minus root 3. So multiply in numerator and denominator by 4 minus root 3. We will be getting root 6, keep it outside, into 3 minus 2 root 2 into 4 minus root 3. Let me write it once. 3 minus 2 root 2 into 4 minus root 3. And the whole divide by 4 plus root 3 into 4 minus root 3 will become 4 square minus root 3 square. Now, in numerator, we have root 6 into 3 minus 2 root 2 into 4 minus root 3. Let's multiply one by one. 3 4 is 12 minus 3 root 3 minus 2 root 2 into 4 is 8 root 2 plus minus minus plus. So 2 root 2 into root 3 will become 2 root 6. Divide by 4 square is 16. Root 3 square is 3. So 16 minus 3 is 13. So we have root 6 upon 13. Inside the bracket, we have 12 minus 3 root 3 minus 8 root 2 plus 2 root 6. So I don't think there is much of simplification possible, right? So this is where we can leave it, and this is the answer of the question. Don't worry too much about the beauty of the answer. Okay. So this is where we have completed the questions related to trigonometry. Remember, in your exams, trigonometry is not going to be asked at a very high level, right? Here also, even in this exercise that we just did, I have taken some questions which are of higher level as compared to the requirement that you have. All right. So you go through the video once again, and if you have any trouble, you can always get back to us. God bless you. Take care.